Bismillah ar-Rahman ar-Rahim. The first part to talk about in this series of ABG interpretations is the physicochemical character of the plasma. We have mentioned before that the compartment we are dealing with is the extracellular fluid, and this extracellular fluid, which is composed of the plasma and the interstitial fluid. This forms about 20% of the body weight. It forms about 14 liters. And these 14 liters are this compartment. The physical character of this compartment is very important to study. It is formed of water, which forms about 90%. Dissolved in this water, we have protein, 8%. Inorganic salts like sodium, potassium, calcium, carbonate, phosphate. And in addition to these organic salts, you can add, and you should add, carbon dioxide, oxygen, and nitrogen. This is very important. When we deal with this compartment, which is extracellular fluid compartment, we have to know that the stability of this compartment is important. There is some what we call electroneutrality, which is the positive charge equals the negative charge. And this is maintained by different organs we are going to discuss. Mass conservation. The composition is nearly constant. Something has been added and removed. Something has been added by ingestion or by digestion or by intake from the gastrointestinal tract. And another, after the metabolism, something has been added. So what has been added for the stability of the cells, and what has been added from the cells to this compartment, this other organs which deal with that, to get rid out of it in order to keep the stability of the composition of this compartment. Another important point, which is dissociation of strong ions and weak ions. The dissociation of weak ions has a constant dissociation, and this dissociation constant is important for the integrity of this system. When you look at the composition of this plasma and interstitial fluid, you will come to a very important fact, that the two together is one compartment, which is separated by the capillary, and therefore the composition is nearly the same for sodium, potassium, calcium, magnesium, bicarbonate, everything, except when you come to the protein. The protein in the plasma is larger for sure than the protein in the interstitial tissues. And the difference between the two, if you come to the protein and divide it by its molecular weight, you'll find that the plasma protein will form about 1.2 millismoles per liter, compared to the protein in the interstitial fluid, which forms about 0.2. So the difference is 1. When we sum up all these osmoles together, or millismole together, you will find it the total is 301, or 300 in the interstitial. The difference is 1, and the difference between the two is the difference between the protein and the plasma, which is higher and larger than that of the interstitial tissues. When we correct it due to the interchangeable activities of these charges of these osmoles, we multiply it by 0.9, you will come to the fact that the corrected osmolality is 282 for the plasma and 281 for the interstitial tissues. The difference is 1. This one is the increase, is the difference in the higher plasma protein than the interstitial tissues. What about the pressure of this? Is millismoles per liter. How much the pressure produced by these millismoles? We multiply it by 19 to give you an osmotic pressure for the plasma is 5,443 millimeter mercury, but for the interstitials is 4,502 23 millimeter mercury. The difference is 20 for sure. This is 1 millismoles increase in the plasma protein than that of interstitial. What we call is oncotic pressure. So this compartment, which is extracellular fluid compartment, contains, as we have mentioned, carbon dioxide, protein, organic and inorganic oxygen, nitrogens dissolved in water. And this forms a volume. And this volume, the stability of this volume is very important for the hemodynamic states. This is not the problem, our problem now for discussion. But this composition is formed of particles which form osmolality, as I've mentioned before, and we're going to discuss later. And all of them, they carry charges, and these charges are important for the pH control or the transmembrane potential. The stability of this compartment from water, carbon dioxide, protein, and organic, in addition to oxygen and carbon and nitrogens, is maintained stable or nearly oscillates very minimal by the integrity of different systems: gastrointestinal tract, respiratory, liver, kidney, and musculoskeletal systems. And all of them are very important to keep the milieu, to keep the charges, to keep the osmolality, to keep the volume of this compartment nearly constant. So if something wrong happened regarding the lung, the liver, or the kidney, or the gastrointestinal tract, or the musculoskeletal system, for sure this will have some sort of changes regarding the volume, osmolality, or charges, and this is what we are going to discuss through these lectures. The study of these problems usually goes under certain laws what have been written by Stewart, which is in the form of water dissociation equilibrium, electrical neutrality, water weak acid dissociation, conservation of mass, bicarbonate ion formation equilibrium, and carbonate ion formation equilibrium. All this we will discuss it while we are going to have a look at the ABG interpretation. And thank you.